All right, how's it going, ladies and gentlemen? Welcome. Sorry I can't be there with you here today, but on the bright side, you may be witnessing the launch of my YouTube career, so you can always say that you were there first when it happened. So tell your grandkids about it. All right, just because I'm not here doesn't mean we're not going to get some stuff done, so hopefully you had a chance to finish up the do now already, like instructed. So you should have had this done already, but let's talk through the warm up here before we get started. It says that. We want to reflect the image of trapezoid ABCD over line XY. Over line x equals 6. So here's that line x equals 6. And let's go on the x-axis where it's 6. And so that's the line they're talking about, the one that's right along that path there. So we want to reflect this over here. So where we should end up is right there. Alright, and there's our new trapezoid rather. Man, I'd be doing a lot of push-ups if this was real class, wouldn't I? Okay. So this probably maybe looks familiar to you from like 8th grade or times like that when you've done this type of thing. But what technique do we use to reflect the triangle? Well, what I did, I kind of did it quick, is I just counted. I just counted 2 units to the line of reflection, 2 units the other way. So we just went 2 units away. And then I noticed that D went to A, I went up 1, left 2. So I kind of did the opposite over here. I went up 1, right 2. So my technique here was just mainly counting to make sure that what I had on the left originally matched what I have in the reflection on the right. How do we describe that line that separates the pre-image from its image, the original versus the new? By the way, guys, I recognize that it's a little bit blurry here. That's the best resolution I can get it. So bear with me here. Just make sure you're following along on the notes. But how can we describe that line? Well, we could say that that line is right in the middle. That's what we could say. But if we really want to get deeper here, it's not just that it's right in the middle. It's creating the reflection because it is a perpendicular bisector. And that's key. We've seen that line a lot. We're going to kind of see what qualities this line has as a perpendicular bisector that makes it the line of reflection, in other words. Okay, now that we've got that done, we've got that reviewed, let's turn this over. Read our essential question. Who wants to read it out today? Oh, Carlos, thanks so much for reading it out. That was great. You did a great job reading it. How do we reflect R, an image across a line of reflection? Notice that little lowercase r there. That's going to be, you could probably figure that out based on what we saw for rotations. Okay, so how are we going to reflect an image across a line? That's our goal today. So if we look at this example here, it says triangle ABC is reflected across segment DE and maps onto triangle A prime, B prime, C prime. So DE would be the line of reflection. Those are the lines where the line we spent exploring on the do now. Okay, let's explore this together based on the instructions. It says, let's use something straight to connect A to A prime, and then C to C prime, and then B to B prime. Okay, let's just use our compass next to measure the distance from these points to DE. So like if I measured from here to here, that distance should be exactly the same as that distance here, right? And that would be true for C and C prime, and it would be true for B and B prime. Okay, so what would we say? What do we notice? We could say each corresponding point is equidistant from the line of reflection. Each one of those is going to be equidistant. And why is that again? Because we talked about it on the front page. Line DE, it's not just a perpendicular, it's not just a line of reflection, It's a perpendicular bisector. And as we've seen by now in this class, perpendicular bisectors are always equidistant from the endpoints that they were created from. So any point on here is equidistant, but the reason I know that this is the line of reflection is because every point on my original shape is the same distance away from the line of reflection as its corresponding point. All right, so today's all about, we're going to be finding the line of reflection. That's one thing we're going to do. And then additionally, we're going to be actually reflecting things over lines. Okay, let's turn the page. Let's construct the line of reflection. You've actually done this tons of times already. It's even more straightforward than what we saw with rotations. If I want to construct the line of reflection here, I can pick any two corresponding points. So I might not want to pick C and C prime because those are kind of close together. So I'm going to go with two that are a little bit wider apart, but not too wide. We'll go with D and D prime. And I'm going to draw my shape in one direction, my arc in one direction, then flip around. It looks upside down for you. That's okay. Go in the other direction. And bam! Once I connect those 2 points, there's my line of reflection. Had we done that at any other 2 corresponding points, like let's say I started at C, if I wanted to make my compass that small, or I wanted to widen out to B or to the A's, I would still get the same line. So unlike rotations, we only have to do this once. Okay? We just connect 2 corresponding points, draw that perpendicular bisector, and we're in business. What's true about the line of reflection? Well, it's equidistant from each corresponding point. It's exactly in the middle. It's creating the mirror image. It's like that mirror that you look in every morning to see how pretty you are. It's the exact same thing. Okay. Whenever we talk about reflections, let's go down into the specifics here. Again, sorry it's so blurry. We talk about a reflection across a specific line. So all reflections happen across a specific line. Just like if you want to see your reflection, you have to be looking into some kind of reflective device like a mirror or your cell phone while you're snapping in class. So here's the definition. Here's the function notation for reflections. Notice the similarity in structure to what we saw with rotations. If we wanted to talk about a reflection across line L with a cursive letter, that's a cursive L, we would say that here we have that lowercase r, that's the reflection. Then what comes next is your line of reflection. And then in parentheses is your image, so that's what we started with. In this point, it's just general. It's just saying some point, point P. And then what pops out is the, ooh, I made a mistake. So we start with the pre-image, and then what pops out is the image. So original, new, okay? And then if you wanted to read that, equation, you would call it the reflection of figure P across line L maps onto figure P prime. Maps is just meaning that it's going to fit exactly on top of it, okay? Sometimes you might have a line that's called line L, like we saw here. Sometimes a line might be called line AB. Lines can be sometimes named with one cursive letter or with 2 points and arrows. Either way works. Same idea. But notice it's a lowercase r is denoting reflection here. Okay, so now if I ask you to write function notation for reflections, you know what to do. All right, let's go to the next page. And I actually want you to pause the video here so you can practice this on your own. I want you to do example 2 and 3 on your own. You're finding the lines of reflection, and then you are naming them in function notation down below. So 2 and 3, find the lines of reflection. Go ahead.